Hello and welcome to this NASA Goddard Google Plus Hangout on Earthrise, one of the most iconic photographs ever taken by humans. Now, thanks to new data acquired by a NASA satellite that is orbiting the moon right now, NASA visualizers have been able to recreate the experience of the Apollo 8 astronauts as they scrambled to take these photographs in both black and white and in color. This new visualization essentially lets you sit on the shoulders of these three astronauts in their small space capsule, or while they orbited the moon, and experience this moment of Earthrise. I'm Aries Keck here at NASA Goddard Space Flight Center in Maryland, and during this hangout, we'll be taking your questions and talking about this moment in history, how the visualization was made, and the other scientific discoveries being made by NASA's Lunar Reconnaissance Orbiter. To ask a question, just put it in the comment section of this hangout, or in the comment section of YouTube, or on Twitter. We'll be moderating the hashtag Earthrise, all one word. Joining us for this hangout is the project scientist for the Lunar Reconnaissance Orbiter, which is also known as LRO, and that's John Keller. Seated in front of NASA Goddard's Hyperwall is science visualizer Ernie Wright. And joining us from his home in Vermont is space historian Andrew Chaikin. Andrew is the author of the book A Man on the Moon, which formed the basis for the 12-part HBO series about NASA's Apollo project. It was called From the Earth to the Moon. And Andrew, we're going to go to you first. Can you set the stage here for this moment in history that we're going to watch a little bit in this hangout?
Well, sure. Hi, Aries. Thank you. This is one of the most incredible moments in the history of exploration. Apollo was the program that landed humans on the moon, and we rightfully focus on the moon landing as the big triumphant moment for Apollo. But really, in a human sense, it was Apollo 8 that really kind of was a climax, because it was the first time humans left their home planet and journeyed to another world, when Frank Borman, Jim Lovell, and Bill Anders fired their booster to go out of Earth orbit and then make a journey of about 230,000 miles to go into orbit around the moon. And I wrote about this extensively, and I talked to the astronauts, and I thought I knew everything that there was to know about Apollo 8, and particularly about the moment that we call Earthrise. But what's amazing is how this new Lunar Reconnaissance Orbiter data has allowed Ernie Wright and his colleagues at Goddard to go back and literally perform detective work and uncover new details. And I'll just give you a brief sense of what is so amazing about this. The moment of the Earthrise, you can only see an Earthrise from orbit around the moon. What happens is, and I have my visual aids here, you actually are going over the moon, and your orbital motion carries you around the moon, and as you come around from the far side of the moon to the near side, the side that always faces the Earth actually comes up above the horizon. It actually pops up. What I'd always thought, and most of us had always thought, was that the spacecraft was coming around the moon like so, with its nose roughly pointed at the Earth, or maybe slightly to the side, or something like that. What Ernie was able to figure out from the onboard photography, because there was another camera that was pointed sort of bore-sided with the nose of the spacecraft, like a gun camera on a World War II fighter, that kind of thing. Anyway, those photographs reveal that the spacecraft was actually pointed at the moon and was actually rotating, such that as the astronauts came around from the moon for the fourth time, the spacecraft rotated so that Bill Anders in the right-hand seat could see the Earth coming up. Now, this was something that had happened 3 times before on Apollo 8, but because the windows were pointed away from the Earth as they came around, they didn't see it. And now, as you see in the video, the new video, which is beautiful recreations of the event using the LRO data, but it's also synchronized with the onboard voice tape, and it's a fantastic human moment of exploration. You can hear the amazement in Bill's voice as he sees the Earth coming up, and then Jim Lovell comes up and sees it too, and there ensues a scramble for color film, and finally Anders is able to capture the photo. He took one black and white right away, and then he's able to capture the color shot that became an icon of the 20th century.
And I know we're working on getting some of that video up in a minute now. I wondered, Andrew, as the historian here, I breezed over the 3 astronauts, but who exactly were these men? How many times had they been up?
Right. Well, Apollo 8 was truly the moment at which NASA really could take a giant leap, maybe not to the surface of the moon, but away from the Earth to orbit the moon. And to command that mission, they gave that mission to Frank Borman, who had been the commander of Gemini 7, which was a mission in December of 1965, in which he and Jim Lovell spent 2 weeks orbiting the Earth in a very tiny, very cramped Gemini cockpit to show that humans could survive in space long enough to make a lunar voyage. Jim Lovell, who was his crewmate on that flight, Gemini 7, was also with him on Apollo 8 as the flight's navigator. And the third crewman, Bill Anders, was a rookie who was making his first and, as it turned out, only space flight. And his function on the mission was to be the systems engineer, keep track of the systems, also did a lot of the photographic work and a lot of the business of observing the moon through the spacecraft windows from lunar orbit. So it was and for me as a storyteller of space, as a historian, what I love about the Apollo 8 story is that there's such different personalities. Frank Borman is sort of the gruff, no-nonsense, military-style commander. Anders is the rookie, a little more serious-minded, and Lovell really has a kind of a great spirit that comes through in his comments about the Earth as a grand oasis from space. He designed the mission patch, which was a beautiful figure 8 going around the moon and the Earth. So you have these 3 very different personalities in this spacecraft experiencing one of the most unbelievable moments in the history of exploration.
And now, Ernie, you were the visualizer taking some of this data from a current mission, LRO, and recreating this moment. What inspired you to try to recreate this moment? We already had the audio and we already had the still pictures. Why put the time into taking true scientific data of the moon and recreating something that happened so long ago?
Well, there were a couple of reasons for that. I mean, it started when my wife got me a poster of the Earthrise image for Christmas a couple of years ago. And it was for my office. And so as I sort of unfurled it in my office and looked at it, I said, I've got a ton of great LRO data that maybe I could use to recreate this. And so last year for Earth Day, we released a very simple sort of recreation that matched the photographs with LRO terrain, and I was happy with that one. But as I did the write-up for it, I realized that there was a lot that we didn't know about the circumstances surrounding that photo. So I sort of filed that away. And about a year later, I started to look at some of the other Apollo 8 photography. And I realized, as Andy mentioned, there was a camera that was pointed straight down at the lunar surface, and it was taking pictures every 20 seconds. And right around the time of the Earthrise photographs, you could see that the images that were taken by this camera were rotating. And so, it told me 2 things. It told me that the spacecraft was pointing straight down, and it also told me that it was rolling when the photos were taken. So I carefully matched those photos to the terrain, determined which way the spacecraft was pointing, and that opened up the recognition that there were other things going on, like which window was the Earth visible in. And these are things that we didn't know before. So by the end of it, we knew probably which window each photo was taken from and who took them. And that was really possible because LRO has this amazing global data set that just didn't exist before. We really didn't have a global elevation map for the moon that was good enough to do this. So that's what made it possible. It was this convergence of the data, which I work with all the time, and the idea of seeing if we could, recreate Earthrise just as a way to, it's, in a funny way, it's a way to ground truth the data. You know, if you can match that to a photograph taken by somebody who's actually there, you know everything's good. And it made me very happy when all of that came together.
That's fantastic. One of the things you brought up, and the reasons this made it possible, was the spacecraft that is currently right now orbiting our moon, LRO. I'm going to try to say it one more time, Lunar Reconnaissance Orbiter, LRO. John Keller, you're the project scientist for LRO. Can you tell us what that spacecraft is doing, what instruments are on that as it's orbiting the moon right now? Oh, and John, I think your microphone's muted. You got to unmute the microphone.
Sure.
Hey.
LRO went into space in June of 2009. It's a mission that's both an exploration mission and a science mission. There's 7 instruments on there. The 2 that I should highlight are the laser altimeter and the camera system, because those are the 2 that were used by Ernie to recreate the Earthrise, and so we have been, you know, with the laser. It's an advanced laser that has pinged the moon 3 billion shots over the time, and you just measure the time of flight for the laser to hit the surface and for it to come back, and that tells you the surface, how hot, you know, the distance to the surface, and you get the shape of the moon. Prior to LRO going into space, we actually knew the shape of Mars better than we did the moon, and now we know the moon and the shape of the moon better than we know any planet, including Earth. And the Earth, because so much of the Earth is underwater, that we don't know the topography that well.
John, I have a quick question for you on that. When you're shooting this laser down to the moon's surface from the orbiter, is it affecting the moon's surface at all, or is it like those little lasers we play with our cats, where it's just a light?
It's very it doesn't affect it at all, because it's first of all, it's not a very strong laser. Second, it's broken up into 5 different spots, so simultaneously we hit the moon with 5 spots. And then third, the distance from which we were lasing from, you know, most of it was 50 kilometers up, so the spot size is spread out quite a bit by the time it reaches the moon. And then the other part is the camera, and what Ernie has to do is he takes the full moon has been created, has been photographed by LRO at 100-meter resolution, and he lays down the images of the that were taken by the camera onto this topography, and by doing that, that's what you're seeing in his video, and really able to match what the photographer Bill Anders was seeing on the Apollo 8.
Fantastic. I know we're going to pull up some of the just a segment of this recreation that Ernie's created. The entire length of the video that we put out today is a full 6 minutes long, and it incorporates both some of the visualizations and some archival footage of the Apollo astronauts themselves, and you'll find that link on our Goddard Google Plus page. We'll have it on the YouTube page shortly, and it's out on nasa.gov as well. One of the things, we're getting questions in. I wanted to remind everybody, we're taking your questions. If you go #Earthrise, I'm following along here on an iPad, or put the questions in the YouTube section and comments, or on Google Plus. And I have a question that comes from someone by the name of Tyler Waldrop at Shadow404. And now we're holding this. Next week is the 45th anniversary of this event. Tyler wants to know how old each of us was back when Apollo 8 was happening. I'm not going to answer that, though I have an easy out in that I wasn't even around then. But was anybody else in the Hangout, were you at an age where you remember this event or any of the Apollo program?
Well, I'll jump in and say that, you know, for me, every Apollo mission, I was glued to the TV. I was 12 years old, and I had my little mission control in the den with my maps of the moon and my models of the spacecraft and copies of Time and Newsweek, and, you know, I was doing everything I could to, you know, vicariously participate in the mission. So, yes, I remember it as one of the great moments of my growing up.
Yeah, for me, I certainly remember the Apollo 11 landing, and I know I was in 5th grade at the time.
I was 6 years old, and remember. What I remember most clearly is 11 because my parents let me stay up late. 11 landed in the afternoon, but they did their first spacewalk at about 10:30 Eastern time, and that was way past my bedtime, but they let me stay up and watch it, and so that memory is imprinted. But, when you're 6, you think you go to the moon every day, and so that part of it didn't make a big impression on me until I was much older, and I was grateful that I could see that as a it's in my living memory, but it took a little while for me to understand the significance of it.
That's fantastic. We have another question as we get the video with the audio queued up. We're going to play a little bit of it so you'll be able to hear the astronauts as they grab cameras and take this image and part of the gorgeous visualization that Ernie Wright put together. Please keep asking questions at #Earthrise. I'm Aries Keck here at NASA Goddard Space Flight Center, and we're talking about this amazing image. And actually, while we also still have Ernie up, he's sitting in front of a hyperwall, which is a whole bunch of big flat screen TVs that we use here for science visualizations, and that's the image we're talking about. This image of the Earth actually rising, just like how the sun rises when we're here on Earth. The Earth rising over the horizon of the moon. One of the next questions we've got is at VR Doug, and what he wanted to know is what about this VR? What photorealistic? I think he's asking what makes this photo realistic. And I'm wondering, Ernie, that's a question for you. Was it in lining up the sort of the original image and then taking the new LRO data with its really high quality information and lining up to make it essentially a recreation?
That's exactly right. For every photograph that you see in the video, I was using animation software and positioned a virtual camera over a model of the terrain, and I really did this by eye. I moved the camera a little bit this way, that way, changed the direction that it was pointing until I got an exact match with the photographs. And that information tells you something about which way the spacecraft is turning too, because once you get the camera in the right place, you know that the real camera was in a certain position and pointed in a certain direction. So the visuals and the understanding of the geometry kind of created a feedback.
Fantastic. And hey, Andrew, wanted to ask you again real quick, is it unusual for historians to use these types of animations or computer recreations to see things from a new angle or a different angle, or is that becoming something that historians use quite a bit for different aspects?
Well, it certainly wasn't available 25 years ago when I was writing A Man on the Moon. I mean, my recreation was in my mind using the onboard voice tape, my delving through the transcripts of the communications, the post-flight debriefing, and of course my interviews with Frank Borman, Jim Lovell, and Bill Anders. What's so neat about being able to revisit this now with today's technology is that, first of all, we've got images from LRO that are so good. I mean, if you go on the web and you Google LRO Apollo landing sites, you will see images that are so good that you can literally see the astronauts' tracks that they made with their feet disturbing the lunar soil. So that gives you some idea of how powerful the cameras are. And then as John pointed out, when combined with the really beautiful laser altimetry data on the topography, that nails down the three-dimensionality of the moon. And the last piece of the puzzle is this ability to do computer-generated scenes that can be viewed from any realistic viewpoint, and there are realistic computer models of the spacecraft we can use. And as Ernie said, you set up a virtual camera. So is it unusual? I think probably nowadays it's going to become more and more common, but it's sort of the old maxim about computers in general. If your data's no good as they used to say in the old days of computing, garbage in, garbage out. And what's so great about this is the data is so good that the historical conclusions that come out of that data, and it's been interpreted so beautifully by Ernie and his colleagues, the historical knowledge that comes out of that is so good that it matches up precisely with everything we knew before. You can, in fact, one little detail that I'll share, the tape, one of the things that Ernie noticed on the tape, I'm a little embarrassed that I didn't notice this 25 years ago, but Ernie beat me to it, is that you can literally hear on the tape when Bill Anders clicks the shutter on the Hasselblad. You hear the shutter and then the motorized film advance as he takes each of these three photos, first the black and white and then the two color. And that allowed him to precisely place the audio with the recreated motion of the spacecraft and the visual of the moon. So it is a full, literally a full recreation of the event. And I'm just glad that technology has progressed to the point where we can do that. I mean, it would have made my life a lot easier 25 years ago, but better late than never.
That's great. Well, the biggest comment we're getting now from everyone is play the animation already. So we're going to mute our microphones and we're going to share this, just a snippet of this longer video. You can see the full-length video at the website. And let's all mute our mics and they're going to play some of this with the audio of the actual astronauts.
All right, we will. Set. The impact crater with at just prior to the subsolar point on the south side, and the floor of it fairly even, except there is one dark hole, but I couldn't get a quick enough look at it. See if it might be anything volcanic. Oh my God, look at that picture over there. There's the Earth coming up. Wow, that's pretty. Hey, don't take that, it's not scheduled. Got a color film, Jim? Hand me a roll of color, quick.
Oh man, that's great. Where is it?
Quick. It's out here. Just grab me a color. A color experience. Hurry up. Got one?
Yeah, I'm looking for one. C368.
There you go. Quick.
Here.
Honey.
Oh, yeah, I got it right here.
Let me get up this way. Not clear. Bill, I got it phrased. It's very clear right here. Got it? Take several. There's several up here. Hey, man, let me get the right setting here. Hey, calm down, Mama.
Oh, I got it right. Oh, that's a beautiful shot. 250 at F11. Now there's explosion.
I did you up.
You sure you got it now?
Yeah, it'll come up again.
That was fantastic. I love hearing them argue a little bit of like, I got it, we're fine, I got it. And Andrew Chaikin, remind us again just who were the three gentlemen we just heard talking, and that was the audio, the original audio with Ernie Wright's brilliant recreation of that moment as we were out in space looking at the Apollo capsule. Who are those three guys we just heard talk?
Right. So So the first voice you hear is Frank Borman, the mission commander, who's over in the left seat, left-hand side of the spacecraft, and he announces that they're about to perform a roll maneuver, which is in the flight plan. The reason he's doing it is because he wants to rotate the spacecraft so that Jim Lovell, the navigator, who's down in the lower equipment bay, can use the onboard sextant to sight on lunar landmarks. Anders, meanwhile, is in the right seat. He's looking out his window at the moon and making observations into the tape recorder for the benefit of the scientists back on Earth when they hear those tapes. When the Earth comes up, as the spacecraft rotates and Anders suddenly sees it coming out his side window, he says, "Oh my God, look at that picture over there." And Borman jokes with him and says, "Don't take that, it's not scheduled." And the reason Borman says that is because earlier in the day, while they had, pretty shortly after they had fired their engine to go into lunar orbit, they were looking down at the moon and they were amazed, and Frank Borman wanted to take a picture, and he asked Bill Anders for the camera, and Bill was the keeper of the photo plan, and Bill got very kind of intense about it. And you can hear on the onboard voice tapes, Frank says, "I just want to take a picture." I mean, he's just like tourists everywhere. So when it comes to this moment of the Earthrise, it's Anders who has the camera, and Borman, who's flying the spacecraft, just kind of gives him a little jab there about, "Hey, don't take that, it's not scheduled." And indeed, it wasn't scheduled, because this was a complete surprise. Then you hear Lovell come up from the lower equipment bay to join Anders at the window. You hear him say, "Oh man, that's great." Anders, meanwhile, who has already taken the black and white, is now intensely focused on getting a color magazine so he can slap that on. It takes Lovell a few minutes, several long moments, to find it. By that time, the Earth has disappeared from the side window because the spacecraft's still turning, but now it's in view in the rendezvous window, which is right in front of Anders, and also the center hatch window, which is actually kind of cloudy. It actually is kind of surprising that Lovell said, "I've got it right here, it's very clear," because really that window was pretty well clouded up. But Anders has the telephoto lens, and he aims it through the rendezvous window and takes the color pictures. And then at the very end, one last little touch, and this was something that I played the tape sitting next to Bill Anders in his office in 1987, and you hear Lovell say, "Are you sure you got it now?" And Anders kind of dryly says, "Yeah, I think it'll come up again."
And that leads us beautifully to a question we have coming in. And please bring your questions in as we go through and take out this tape. The entire long visualization is available on the internet at that URL behind me. John Heasley wants to know, was the crew of Apollo 8 able to see the Earthrise on later orbits? And how about other missions? Andrew?
Yes, and in fact, this was a bit of research that I had done before Ernie and I got hooked up. This was several years ago. I just took there were later Earthrise photos taken with a wider lens, an 80mm lens. And for example, if you've ever seen, you collectors out there, the Look magazine special issue on Apollo 8, you see a very wide view of the horizon, a very small Earth peeking up above it. Those photographs were taken, I think, Ernie, on what, the 6th and 7th orbits of the moon, whereas the ones we're looking at here were the 4th orbit, so several hours later. And we know that Bill had the 250mm telephoto lens when these ones that we're looking at now were taken. The fact that it was the wide lens suggests that it was probably Borman. In fact, you can see the outline of Borman's rendezvous window, I think. Isn't that right, Ernie?
Yeah, it was actually orbits 5 and 7. And because I was able to find the cloud map, the cloud pattern for the Earth, and match that, it's very easy to match up, the times that those photographs were taken. I think it's even the case that on orbit 7, the transcript has Frank saying, guess what just came up again? And he's talking to Jim, and he says, and Jim says something else, and he says, no, it was the Earth. And so I'm fairly confident that Frank took, about 12 of those pictures with the shorter lens.
Right.
But we've matched those. I've matched them up as still images as well, and maybe at some point we'll put those out too. but it was definitely Orbit 5 and Orbit 7 that those. And I have that Look magazine issue, by the way.
And there were Earthrise pictures taken on the later missions. Every crew that went to the moon talked about the Earth as Stu Ruza from Apollo 14 told me the Earth was the magnet of the flight. And that was the way they all felt, that yes, it was amazing to look down at the moon, but seeing the Earth from that distance was truly the high point.
Thank you all so much. Please continue bringing in your great questions on Twitter at #Earthrise or in the Google Plus Hangout. Several people have been asking whether the LRO spacecraft, the Lunar Reconnaissance Orbiter, the one that's orbiting the moon right now, is taking Earthrise images. And that seems like a perfect question to John to talk about sort of the point of LRO and if it's getting any Earthrise images or not. John?
It turns out that the way the high-resolution camera on LRO works, it's very difficult for us to recreate an Earthrise. Although we have looked back at the Earth in the past and taken images of the Earth, and one example is where we did a solar eclipse where we actually imaged the shadow of the moon on the Earth. But mostly LRO is concentrating on its science objectives. As I mentioned earlier, it has 7 instruments. Just very quickly, there's a radiation detector on there that has a tissue equivalent plastic, and we study the radiation environment at the moon. There's a lunar radiometer where we measure the temperature of the lunar surface and measure the coldest point measured in the solar system, and that is in these areas at the poles, the permanently shadowed craters of the poles. We have an imaging UV spectrometer that's concentrated on looking for water in some of these permanently shadowed craters, and also looking at the atmosphere, or the exosphere of the moon. It doesn't really have an atmosphere. There's a neutron detector that was contributed by the Russian Space Agency. The altimeter, which we talked about, and the cameras. There are really 2 camera systems. One is the wide-angle camera, which is what Ernie used to recreate these, and then there's a narrow-angle camera, which had from 50 kilometers up 50-centimeter resolution, and those are the ones that was the camera system that we used for the Apollo landing site images. And then finally, we have Mini RF, which is a radar system. So we're able to make measurements of the lunar surface using radar.
And now, John, I have a question you probably get all the time, which is, are you doing all of this studying of the moon so we can ultimately live there or build a moon base there? Is it pure scientific discovery? What's the point of gathering all this data, aside from the fact that the moon is just beautiful?
Well, LRO started its life off as an exploration mission, and so we were interested in scouting potential landing sites for robotic missions as well as human landers. Really, LRO is creating the maps that will be used for generations for any number of purposes. It's just depending on how the space agencies of the world want to use that data. But then also, the moon is a witness to the history of the solar system. We're very interested in, for example, the cratering on the moon. We study those craters carefully in order to understand the asteroids' impacts on the moon throughout solar system history. Because the moon is right next to the Earth, by studying that, we know we can say something about what was happening on the Earth in those early times. Whereas on the Earth, because of the Earth's atmosphere and plate tectonics, most of that information has been wiped out. So the moon is our touchstone for understanding the early history of the solar system.
Thank you so much. And just a reminder, that's John Keller. He's the project scientist for the LRO mission. Joining us also is Andrew Chaikin. He's a space historian. And Ernie Wright, who's a NASA Goddard visualizer. And I'm Aries Keck here at NASA Goddard Space Flight Center. And we're talking about Earthrise, the iconic image that you can see right now behind Ernie. And that was taken by the Apollo 8 astronauts. And also this beautiful recreation that we've done using LRO data. I have a question that probably leans more for Ernie. Ernie, people are asking a little bit about how to get your job. You sit there and make awesome computer animation, real data. Two questions for you. One, could you talk a little bit about what you do and how this is different from what Pixar does? You know, you use true scientific data. And another question that falls into this, a lot of people are asking, apparently the new Gran Turismo video game has a moon track where you race cars on the moon. Did you know about that? Were you involved with sending them any of this data so they could build a racetrack on the moon in that video game?
I was not directly involved in that, but I can tell you that all of the data from LRO is being archived publicly. It's in the planetary data system, and I think if you just search for LRO PDS, you'll find that all of the terrain data and the albedo maps and a lot of the other data is out there, and so anybody who wants to do this can. I have had inquiries from movie makers over the past couple of years who, because we talk, happen to know that I'm working on moon stuff, and they've asked me where this data is, and I just send them a link to the PDS. So I didn't know about that particular game, but I know that imagery of the moon is getting better all the time, and it's because we have all this great LRO data, and it's all publicly available. As far as what the studio does and how it's different from other animation studios, we use a lot of the same software. We use Pixar's renderer, and for this one I also used a little bit of Lightwave. But what makes it different is that everything we do is driven by data. So we're not allowed to make anything up. We get short-tempered with people who come and ask us to make things up because we don't know how. Our skills are really for taking data from scientific missions and showing them to other scientists and to the public in ways that sort of illuminate what that data means. And we have a website with several thousand of those animations that you can go to, and if you search for SVS, you'll find it. If you want my job, most of the people that work in our studio have computer science backgrounds. We also have someone with a Master of Fine Arts, and we have an astrophysicist. And so you bring your programming skills and your interest in space science and some experience with animation, and we'll look at your resume. Although I'd like for it not to be my job, I'd like for it to be another opening. But it's an odd skill set. I mean, it's not a set of skills that everybody has. So we're a very tight-knit group, and we do a lot of custom programming. That's the reason for the computer science background. We need to, almost every time, write programs that translate scientific data into forms that can be used in animation software. And we also have to apply a little bit of judgment about what a valid visual representation of this data is. Because it's pretty easy to misrepresent data if you just start goofing around with it and paste it wherever you like. So those are kind of the things that we do on a daily basis.
Fantastic. I'm going to try to go through some questions real quick. Thank you all for sending them all in. At Iriodana wanted to know if Earth was the only planet that they were able to see from the moon. Ernie, you're not. I don't know if you want to take that. I know Andrew probably also knows the answer. But did the Apollo astronauts try to see other planets while they were up there in their orbiter?
Well,
yeah, go ahead, Ernie.
All right. The thing I will say about that is that it probably surprises people not to see stars in a lot of these images from Apollo. And that's because most of the time they were in daylight. And the astronauts themselves said that they didn't see stars until they were not only on the side of the moon that was not illuminated by the sun, but also on the part that was not illuminated by the Earth. And when we see that from the Earth, we call it Earthshine. But they really needed to be in complete darkness before they started to see the rest of space. And then when that became apparent, it was beautiful. But they didn't see it all the time. I don't know, and Andy may know, I don't know whether Apollo 8 saw any of the other planets. I know they saw stars, and they used stars for navigation. But there were many times when they couldn't see them because they were literally in daylight.
Yeah, that's right. I mean, this is one of the things that, there is a small minority of people who actually don't believe that the moon landings happened. And one of the things that they always say is, hey, if they are on the moon, how come there are no stars in the photos? Well, the fact is that the stars are, millions of times fainter than the sunlit surface of the moon itself. And so whether you're looking at it with your eyeball or photographing it with a camera, you've got to have the right conditions to see stars in the daylight. And there's only one example that I know of where a planet is recorded in a lunar surface photo. It's a photograph from Apollo 16, and it does show Venus if you know exactly where to look in the photo. And it's only, one little bright dot, because Venus is extremely bright. And, we can see Venus even here on Earth. If you know exactly where to look, sometimes you can see Venus in the daytime. But in general, as Ernie said, even if you're standing on the surface of the moon, if you want to see stars, you'd have to go into the shadow of the lunar module and let your eyes dark adapt before you could really see them. Otherwise, you're really just, everything's washed out by the brightness of the landscape itself.
And we're getting questions in fast and furious here. One of the questions that have come in, people are asking, what part of Earth are they looking at? And I actually was squinting at the image behind Ernie trying to see if I could see a continent there. Andrew, what part of Earth is seen in Earthrise? And then the follow-up question is, people are asking, does it change as the capsule spins and as the moon goes around Earth?
Well, Ernie really nailed this down, so I'll let him talk about it.
Okay. The Earthrise image that was taken on the fourth orbit shows the western coast of Africa at the bottom. And north is to the right in that image, and Antarctica is visible on the left side of that image. And South America is coming into view at the top. On later orbits, Africa has moved into nighttime. And South America is central in those pictures. So yeah, the Earth is rotating. It took them about 2 hours per orbit. So the Earth would rotate 1/12 of the way around in between each orbit. And the Moon is also moving a little bit, and that has a smaller effect on what part of the Earth is visible. Those changes are absolutely visible in the photography that they took.
Fantastic. One of the questions we're getting, that I think someone who speaks for the robots is noting that this was the first Earthrise taken by humans. Now, Andrew, you probably know this as well. What was the first Earthrise image then ever taken? I have the answer here because they've been sending it to us. But
right, and I think I maybe know who that person is who's asking that question.
I think I do too.
They're absolutely right. The first image of an Earthrise was actually taken by a robotic probe called Lunar Orbiter. And I don't remember which Lunar Orbiter it was. I have a feeling it might have been Lunar Orbiter 4, but I'm not sure. In 1966, I believe, it was a black and white image. Because of the way that the Lunar Orbiter probes, not to be confused with today's Lunar Reconnaissance Orbiter, the Lunar Orbiter probes, which were the first to create detailed photographic maps of the Moon, had an unusual image system where they actually shot photographic film on board, developed that film on board, and then scanned the resulting developed film and transmitted that as brightness variations to the Earth, and that was then reconstructed into an image. So when you see one of those lunar orbiter images, they're kind of like strips put together. Now, a recent project called the Lunar Orbiter Image Recovery Project has done some beautiful work reconstructing those images from the original data tapes, and they're much more, they're much nicer presentations of those images than we had at the time. And one of the images that they've recreated is that Earthrise image from Lunar Orbiter. So if you Google LOIRP for Lunar Orbiter Image Recovery Project and Earthrise, you will find that recreated image. But the difference was, just to add the historian's perspective here, there's no comparison between a camera that is robotically controlled and a camera held by a human. I'm a big fan of robotic spaceflight. I'm a huge fan of robotic spaceflight. But once the astronauts got to the moon, the fact that you had a human taking that picture who could then come home and talk about what it was like to see that, it just struck a chord on a much higher, more intense level for the entire world.
Fantastic. We're having some questions here as well about what the orbiter we have around the moon right now. So I wanted to throw it to John. And behind you on your bookshelf is, I believe, a globe that shows the topo map that LRO was able to create of the moon in all those beautiful colors. What was the point of creating a very high-resolution topo map of the moon and putting it in those, to our eyes, odd colors instead of the black and white that we're used to seeing?
Well, I think the reason for the coloring is it makes it to a person looking at the moon. You can quickly see where the high points are and where the low points are. One of the reasons, one of the science reasons for making these maps, just as an example, we by looking carefully from both the high resolution images and the topography, we're able to see features on the moon that indicate, for example, that the moon, this is one of our science discoveries, that the moon is still in a state where it is still shrinking. Now, of course, it's extremely slowly shrinking, but it shows up tectonically in wrinkle ridges on the moon that the geologists, they recognize those from comparable features on the Earth and other planets, Mercury, for example. They recognize that. They see we've discovered that these ridges are globally distributed using these data, and so we determined that the moon is still in a state of cooling and contracting very slightly. But the reason it's important is that then we can go back and say, gee, what was the state of the moon when it was formed? Did it have a fully, did it have a solid core, or was it in a melted state? And knowing a little bit more about the thermal state of the moon now allows us to constrain those models of the moon when it was originally formed. So the topography has a lot of science drivers for it, but then, as I've said, it's also a map for future explorers.
I can see the headlines already. NASA says the moon is shrinking. When we say it's shrinking, are we talking millimeters? Something that only geologists would notice, or?
Yeah, it's extremely slow, and geologists think a short period of time for a geologist is 100 million years, and so in geological timescales, it's shrinking, and we know that these features are relatively new in geological times, because we look at the cratering around those features, and if there were a lot of craters over the features, then we would say, gee, it's old because it's had time for the meteorites to age it, and then the fact that these features look fairly fresh tells us that they're relatively new. And new, again, in geological speak, is 100 million years, 300 million years. A long time is billions of years.
Geology time is a whole different time scale than what we're used to hearing. Speaking of new, those of us here on the East Coast recently saw a rocket launch that carried another moon mission that went up, LADEE. John, can you tell us a little bit about what LADEE is doing in its studying the moon? And then I can already hear the question, how are we making sure that LADEE and LRO don't swack into each other up there?
Well, LADEE is a mission to the moon that is designed to look at the exosphere of the moon and the dust environment. It is in an orbit that is largely equatorial, and we're in a polar orbit. And so our orbit tracks actually do cross. So we're going like this, and LADEE's going like this, and I've found that I can't do both simultaneously. I've tried. But we actually, our orbit tracks do cross all the time, and the closest we've been so far to LADEE is I think around 10 kilometers. But the fact is their orbit where we cross is lower than ours, and so there's really no danger that we would run into them. You know, even if we tried, it's low probability, but it's really not possible. But it's interesting that, you know, we're attempting to work with LADEE and do some coordinated studies. LADEE, because it's in its equatorial orbit, and it's got some very high sensitive instruments that are designed specifically for their mission, which is to look at the exosphere, you know, what's in the atmosphere of the moon. Yeah, it does that very well. And we have specifically the LAMP instrument, the UV spectrometer on the moon, on LRO, and we're able to measure some of the atmosphere as well. And because we're in a different orbit, we can kind of correlate what their equatorial measurements with our polar measurements and try to get a more global picture of the transport of these very tenuous species that are moving around, you know, in the exosphere.
Fantastic. We've only got about 3 minutes left in this Hangout, and we're getting a lot of questions, and so I'm going to try to do a bit of summaries for some of them. One of them for Ernie. Now that this is done, what are you doing next? As people are asking about. Are you planning on taking the LADEE data? Are you planning on taking a vacation? I mean, I know a lot of work went into these 6 minutes that we released today.
I'm going to take a nap and enjoy the holidays, but as soon as I get back, I'm going to restart with what I've been doing with LRO. They have data that I can't really talk about yet, but we're going to do some cool things with. Yeah, I mean, the data is coming from LRO all the time, and we have to sort of pick and choose what we tell people about. And there will be something waiting for me the first week of January when I come back.
Thank you so much. I have one last question then for Andrew. When it comes to, I mean, you've essentially made the Apollo missions your life's work. What is it about the Apollo missions that for you just keeps you enthralled with them and keeps them so interesting?
It is such a profound moment in human history, the moment when we left our home planet and took our first voyages to another world. And you know, I just find that there's always more to discover about Apollo. Looking at the Earthrise photo now, I couldn't help but think of the quote, the famous line from the great Russian space visionary Konstantin Tsiolkovsky, who wrote that the Earth is the cradle of humanity, but one cannot live in the cradle forever. And I have to admit, I get kind of emotional looking at that picture and realizing that for all of us, that is the cradle. And to see it with those eyes and realize we're still in the process of leaving that cradle. It's taken a little longer than we would have expected 45 years ago. But the fact that we can keep revisiting that experience and getting more out of it is just it's an ongoing joy for me, and I'm just honored to be part of all this.
Thank you all so much. Thank you to everyone who's been watching this live, and thank you to everyone who's maybe watching it later as it's archived on YouTube for all time, hopefully. Joining us has been Andrew Chaikin, space historian and author, John Keller, the project scientist for LRO, the Lunar Reconnaissance Orbiter, which is orbiting the moon right now, and Ernie Wright, who is one of the science visualizers there. We will keep answering your questions throughout the weekend and such. And also, if you go to the @LRO NASA Twitter feed, they have been live tweeting this entire event and will be continuing to post new things, especially since Christmas Eve coming up is the 45th anniversary of this event. So it was 45 years ago, and it's a big anniversary for not only space missions, but I think for all of us here on Earth as viewed from the moon. I'm Aries Keck here at NASA Goddard. Thank you all so much for listening, and thank you, scientists, for taking part.
Thanks, Aries.
Thank you.
Thank you.